Space communications is a tricky business. The Space Communications and Navigation Testbed, or SCAN Testbed, combines software-defined radios that can be reconfigured with new software. David Robison from NASA's Jet Propulsion Laboratory tells us more. Tell us about the GPS experiment on the SCAN Testbed.
Well, to start off with, just to give you an idea of what the SCAN Testbed is and what it's doing, take, for instance, your cell phone. Your cell phone is an amazing device. It automatically connects to whatever cell tower is nearby. If there's Wi-Fi, you can connect to Wi-Fi, connect to the internet that way. There's also GPS in your cell phone that tells you where you are. It's this amazing combination of features that for the most part, all operates automatically. And the SCAN Testbed is a platform that is allowing us to develop similar technologies for space. For space, communication is a little bit more complicated due to the distances and velocities involved, and so, but we're developing next generation technologies for communication, things like a cognitive radio that would automatically connect to whatever other spacecraft or communication links are available and set up networks and forward data. So GPS is actually a very interesting part of that. Having GPS co-located with the radio would allow you to automatically, based on position, set up a radio link, point an antenna in order to connect with a high gain antenna to some relay satellite or a ground station. So for what I'm doing with GPS, basically we are developing software for the SCAN Testbed that will turn it into a GPS receiver. It's this software-defined paradigm where instead of having a dedicated electronics box that just does one purpose, it's a general purpose system that then you can, by writing the appropriate software, enable different features. And so we're demonstrating this concept with GPS on the SCAN Testbed. Specifically for the SCAN Testbed, deploying this GPS software is kind of demonstrating better accuracy for the space station. Currently, our knowledge of where the space station is on the order of a few meters, but using some of the latest GPS technology, we should be able to improve that to about 10 centimeters or so. That's part of what this demonstration is. It's both a software-defined approach for GPS in space, but also improving our knowledge of where the ISS is at any given time. And that's kind of a pathfinder for a new set of experiments that we could do on the space station.
And this is all for future space missions too, right? It's going to help.
Right. So this is a GPS receiver design that could be applied to future space missions. One of the things, the unique benefits of the SCAN Testbed is it's basically a general purpose platform, and so you could potentially make future NASA missions more efficient by having one platform that handles both communication, networking, and location and ranging and GPS receiver applications all on one platform. Similar to a cell phone for space, basically. But the secondary applications are that using GPS in space enable us to make more precise measurements of Earth, things that will benefit us and become very crucial for understanding our climate and how that may be changing.
What's it like for you to be a principal investigator for an experiment on the space station?
I kind of have to pinch myself sometimes, because one aspect of it is that, okay, this is just my work. I'm, going to work, and this is what I'm working on. But on the other hand, it's the space station. This is such a cool opportunity to be part of exploring space and developing technology in space.